All right, everybody, it's Thursday time for another chat loop back off. Today we have Sandipan Panda. We are going to go over OpenTofu. I'll be in the background running chat. Introduce yourself, take it away, and you've got about 55 minutes.
Yeah, thanks, George. Hey everyone, my name is Sandipan Panda. I am a member of Kubernetes and Kubeflow, and I work as a member of technical staff at DevZero. Apart from that, I'm also a CNCF Ambassador. So today we'll be looking at uh, OpenTofu. Like every week, we kind of do this thing called ChatLoopBackOff, where we learn live about a CNCF project. So let's get started. Just a second to let me share my screen. So can everyone confirm that my screen is clearly visible and everything? Okay. So first we'll be looking at the CNCF landscape to get an overview of the OpenTofu project. So let's see. So OpenTofu, it's a CNCF sandbox project. So it is an open source infrastructure as code tool that enables users to safely and predictably provision and manage cloud and on-prem infrastructure. It's a community-driven fork of Terraform that maintains backward compatibility while offering enhanced features stability. So here you can see the OpenTofu GitHub repository, and it has around 26,000 stars, around over 2,000 contributors, and CNCF helps support this project. So, and this is the GitHub repository of OpenTofu in case you would be interested in contributing to its development. Now let's have a look at OpenTofu website and learn more about it. So OpenTofu is an open source infrastructure as code. It is a reliable and flexible and community-driven infrastructure as code tool, as we saw, under the Linux Foundation's stewardship. And here you can see some of the features unique to OpenTofu, like the exclusion flag, provider iteration with for each, and early variable local evaluation, state encryption, which are unique to OpenTofu. Let's have a look at some of the frequently asked questions about OpenTofu, like what is it? So why was OpenTofu created? So OpenTofu is a Terraform fork created as an initiative of Grantwork and other companies in response to Hutchcock's switch from open source to business source license. The initiative has many supporters, all of whom are listed. You can see. So why should you use OpenTofu instead of Terraform? It's like some personal use, like, and you can see those. This one looks important. Will OpenTofu will be compatible with future Terraform releases? The community will decide what features OpenTofu will have. Some long-awaited Terraform features will be publicly available soon. If you are missing a feature in OpenTofu that's available in Terraform, feel free to create an issue. So as you can understand, this is a learn live thing. So I will be looking at this project from a very beginner's perspective, and I will be exploring this project for the first time, just like anybody who is learning about it for the first time. So let's check out the getting started page to learn more about OpenTofu. So we saw what OpenTofu is. Let's look at how OpenTofu works. OpenTofu creates and manages resources on cloud platforms and other services through their application programming interfaces. Providers enable OpenTofu to work with virtually any platform or service with an accessible API. The OpenTofu community have already retained thousands of providers to manage many different types of resources and services. We can find all publicly available providers on the public OpenTofu registry. Let's have a look at it. So this is it, including AWS, Azure, Google Cloud, Kubernetes, Helm. The core OpenTofu workflow consists of 3 stages. The first one is write, where we define resources which may be across multiple cloud providers and services. For example, you might create a configuration to deploy an application on virtual machines in a virtual private cloud network with security groups and a load balancer. The next step is plan, where OpenTofu creates an extension plan describing the infrastructure it will create, update, or destroy based on the existing infrastructure and your configurations. The next step is apply. On approval, OpenTofu performs the proposed operations in the correct order, respecting any resource dependencies. For example, if you update the properties of a VPC and change the number of virtual machines in that VPC, OpenTofu will recreate the VPC before scaling the virtual machines. So why OpenTofu? The first one is manage any infrastructure. Like we can find providers for many of the platforms and services we already use in the public OpenTofu registry. We can also use the Terraform plugin SDK to write our own. OpenTofu takes an immutable approach to infrastructure, reducing the complexity of upgrading or modifying our services and infrastructure. The next reason will be to track our infrastructure. OpenTofu generates a plan and prompts you for your approval before modifying your infrastructure. It also keeps track of your real infrastructure in a state file, which acts as a source of truth for your environment. OpenTofu uses the state file to determine the changes to make your infrastructure so that it will match your configuration. The next step is automate changes. So OpenTofu configuration files are declarative, meaning they describe the end state of your infrastructure. You do not need to write step-by-step instructions to create resources because OpenTofu handles the underlying logic. OpenTofu builds a resource graph to determine resource dependencies and creates or modifies non-dependent resources in parallel. This allows OpenTofu to provision resources efficiently. The next reason is standardized configurations, where OpenTofu supports reusable configuration components called modules that define configurable collections of infrastructure, saving time and encouraging best practices. You can use publicly available modules from the OpenTofu registry as well, or write your own. The next reason for using OpenTofu is collaborate. Since your configuration is written in a file, you can commit it to a version control system and use a cloud backend to efficiently manage OpenTofu workflows across teams. A cloud backend runs OpenTofu in a consistent, reliable environment and provides secure access to shared state and secret data, role-based access controls, a private registry for sharing both modules and providers, and more. And here is some information about the OpenTofu community. So if you have any questions, you can ask them in the OpenTofu discuss. And if you are interested in contributing to OpenTofu, you can check out the contributing guide here, as you can see. And if you find any bugs or issues in OpenTofu, you can submit an issue as well. So the next step is the use cases of OpenTofu, where we can see, let's check it out. So multi-cloud environment. Provisioning infrastructure across multiple clouds increase fault tolerance, allowing for more graceful recovery from cloud provider outrages. However, multi-cloud deployments add complexity because each provider has its own interfaces, tools, and workflows. OpenTofu lets you use the same workflow to manage multiple providers and handle cross-cloud dependencies. This simplifies management and orchestration of large-scale multi-cloud infrastructure. And you can use OpenTofu to efficiently deploy, release, scale, and monitor infrastructure for multi-tier applications. Entire application architecture lets you scale application components independently and provides a separation of concerns. An application could consist of a pool of web servers that use a database tier with additional tiers for API servers, caching servers, and routing meshes. OpenTofu allows you to manage the resources in each tier together and automatically handles dependencies between tiers. For example, OpenTofu will deploy a database tier before provisioning the web servers that depend on it. So this looks cool. And next we can see at a large organization, centralized operations teams may get repetitive infrastructure requests where you can use OpenTofu to build a self-serve infrastructure model that lets product teams manage their own infrastructure independently. You can create and use OpenTofu modules that codify the standards for deploying and managing services in your organization, allowing teams to efficiently deploy services in compliance with your organization's practices. A cloud backend also integrate with ticketing systems like ServiceNow to automatically generate new infrastructure requests. The next reason is policy compliance and management, where you can see OpenTofu help you enforce policies on the types of resources teams can provision and use. Ticket-based review processes are a bottleneck that slow down development. Instead, you can use Sentinel, a policy as code framework, to automatically enforce compliance and governance policies before OpenTofu makes infrastructure changes. Sentinel policies are available in cloud backends. And you can see some more reasons for using OpenTofu like fast application setup, software-defined networking, Kubernetes. So as we all know, Kubernetes is an open source workload scheduler for containerized applications. And here OpenTofu lets you deploy a Kubernetes cluster and manage its resources, example pods, deployments, and services extraction. Parallel environments. So you may have a staging or QA environments that you use to test new applications before releasing them in production. As the production environment grows larger and more complex, it can be increasingly difficult to maintain an up-to-date environment for each stage of the development process. Where OpenTofu lets you rapidly spin up and decommission infrastructure for development, test, QA, and production. Using OpenTofu to create disposable environments as needed is more cost efficient than maintaining each one indefinitely. And software demos for those CNCF speakers who'd like to do some demos in the upcoming KubeCon, you can use OpenTofu to create, provision, and bootstrap a demo on various cloud providers. This lets end users easily try the software on their own infrastructure and even enables them to adjust parameters like cluster size to more rigorously test tools at any scale. Uh, and here you can check out the OpenTofu language documentation. So about the OpenTofu language, the main purpose of OpenTofu language is declaring resources which represent infrastructure objects. Other language features exist only to make the definition of resources more flexible and convenient. An OpenTofu configuration is a complete document in the OpenTofu language that tells OpenTofu how to manage a given collection of infrastructure. A configuration can consist of multiple files and directories. So here you can see the syntax of the OpenTofu language, which consists of a few basic elements as you can see. Let's check those out. So the first thing is blocks. Blocks are containers for other content and usually represent the configuration of some kinds of object, like a resource. Blocks have a block type, can have 0 or more labels, and have a body that contains any number of arguments and nested blocks. Most of OpenTofu's features are controlled by top-level blocks in a configuration file. The next thing is argument. Arguments assign a value to a name. They appear within blocks. Expressions represent a value, either literally or by referencing and combining other values. They appear as values for arguments or within other expressions. The OpenTofu language is declarative, describing an intended goal rather than the steps to reach that goal, much like Kubernetes. The ordering of blocks and the files they are organized into are generally not significant. OpenTofu only considers implicit and explicit relationships between resources when determining an order of operations. So the following example describes a simple network topology for Amazon Web Services, just to give a sense of the overall structure and syntax of the OpenTofu language. Similar configurations can be created for other virtual network services using resource types defined by other providers, and a practical network configuration will often contain additional elements not shown here. So here you can see like this Terraform required providers, and with under this AWS source version and region, base CIC dir block, and availability zones, all these specified. And other than that, here you can check out in more details about the OpenTofu language, like this attributes, checks, data source, meta arguments. You can try this out to learn more about it. So what are tacos? Let's check it out. Seems interesting. TF automation and collaboration software tacos are platforms which allows teams to manage and orchestrate OpenTofu execution. They offer a wide variety of services to provide a streamlined and collaborative experience. So what are some examples? There are a variety of platforms which offer OpenTofu support, both open source and commercial. Okay. Next, let's look at how you can install OpenTofu. So you can install OpenTofu via a wide range of methods. We'll be using macOS. Installing OpenTofu via Homebrew. So you can use OpenTofu as a standalone binary, or you can install it using Homebrew. OpenTofu is available in the Homebrew core repository, so you can install it by running these commands. So let's do this now. So first we'll be running brew update. Okay. Let's wait for some time to work. And up next we'll be installing OpenTofu. To install OpenTofu. So OpenTofu is installed. Let's check out the OpenTofu version to also check it's correctly installed. So here you can see we have OpenTofu version 1.10.2 installed correctly. And next let's do a quick demo to see how you can migrate to OpenTofu from Terraform. So before you begin, OpenTofu aims to maintain compatibility with Terraform configurations. While most Terraform code will work without modifications, we recommend following migration guide to ensure a smooth transition. So if you are currently using OpenTofu, you can follow this to migrate from Terraform to OpenTofu. So the migration process is designed to be safe and reversible. The first step will be to backup your infrastructure state and code, and next install OpenTofu, and then we'll initialize and verify our configuration and test with a small change. So let's see. Mm, This guide walks you through migrating from Terraform to OpenTofu. It's designed to be safe and reversible, allowing you to test OpenTofu without disrupting your existing infrastructure. The prerequisites are an existing Terraform configuration and access to your Terraform state files, and the ability to run both Terraform and Tofu commands during the migration. So first we will have to back up your infrastructure and commit all the changes in a version control. And next we will be installing OpenTofu. We have done those. And the next step will be to run in your Terraform project directory to initialize OpenTofu. So we usually run Terraform init, but instead of that, we will be running Tofu init. So first, let's cd to this directory where we have some Terraform configuration files. Here you can see we have some Terraform configuration files where we'll be migrating from Terraform to OpenTofu. So we already did that. Tofu init. So here you can see Tofu is initializing the background and initializing provider plugins. Same as Terraform. And installing HashiCorp external and all these things. So this command will download required providers from the OpenTofu registry, initialize your backend configuration, and prepare your working directory. So let's wait for some time to get this finished. While this happens, let's check out the OpenTofu GitHub repository. So here you can see the getting help and contributing information. And if you have any question or you'd like to contribute to OpenTofu, feel free to do so. You can check out the contributing to OpenTofu documentation here and some more documentation on how we can get involved. Yeah, you can see like it's a very actively maintained project with issues and pull requests as recent as 5 minutes ago. So if you are interested in learning more about OpenTofu and contributing to OpenTofu, that's a great opportunity. Go ahead. So, wow, you can see that OpenTofu has successfully initialized. Cool. Up next, let's see what's the next step. The next step is to verify your configuration. Run a plan to ensure OpenTofu can read your state and configuration. So we'll run tofu run. tofu plan. So the expected result will be you can see no changes or the same plan output you would see with Terraform. And if you see unexpected changes, do not apply the changes, investigate the differences, and consider rolling back. And up next, if you are comfortable with the changes, the next step will be to apply with OpenTofu. So once you have verified the plan shows no unexpected changes, you can run tofu apply. Even if there is no infrastructure changes, this will ensure OpenTofu updates the state file format if needed. So you usually run Terraform apply, but instead of that, we will run tofu apply. So here you can see some errors, but we need to fix that by checking out as we saw here, we need to debug this. And then after that, you can test with some small changes like make a small non-critical change to your configuration. Example, adding a tattoo resource and run tofu plan tofu apply. This will verify that OpenTofu can successfully manage your infrastructure going forward. And then you can also roll back to Terraform. Like if you encounter an issue during migration, as we saw, you can safely roll back by stop using OpenTofu and restore from your backups and running the Terraform commands like Terraform init, Terraform plan, and verifying no unexpected changes appear in the plan, and continue using Terraform as before. And if you encounter any issues during migration, you can reach out to the OpenTofu Slack and or ask in the GitHub discussions, or if you come across any bugs, you can report those on GitHub issues. So that's OpenTofu for you. So do you have any questions? And here you can check out and learn more about OpenTofu in the OpenTofu YouTube channel as well. And feel free to explore this to learn more about this hands-on. Like you can go through this, like how if you go through the FAQ, you will know why OpenTofu was created and why you should use OpenTofu instead of Terraform, and how OpenTofu will work with your existing state files, and where you can find these providers modules for OpenTofu, and does OpenTofu work with all the providers Terraform works with, and how new features, bug fixes, and other development decisions are made in OpenTofu, and how you can contribute to OpenTofu as well. Like the best way to show practical support for the OpenTofu initiative is to contribute. You can start by opening an issue for bug reports, broken compatibility reports, feature requests, old issue reports, and quality RFCs. Like all major changes to OpenTofu undergo the public RFC process, where we also welcome feedback on existing RFCs. If you are still in the cleanup phase and want to avoid conflicts, please wait until the first alpha release to contribute code. And you can check out the contributing guide here that explains open contribution and recommended practices, including how to submit issues, how to get involved in the discussion, how to work on the code, and how to contribute code changes. Yeah, like Hope you had a great time exploring OpenTofu with me. And you are always welcome to explore more this on your own by going to this opentofu.org website. And we'll see you in the next episode of ChatLoopBackOff.
All right. With that, we don't have a lot of questions, just a lot of thanks. So thank you very much. And we'll see everybody.